Hello there, and welcome to the wonderful world of circles. This is an introduction to our circles and giving you an idea on tangents. Remember, as you go, you want to fill in the theorem sheet that you should have picked up when you started this. If not, make sure you get that. And as you go, you want to fill in the theorems that are talked about, and that sheet is going to be used on your unit test. You want to make sure that you have that. Okay? All right, so let's go ahead and start talking about circles. We got a lot of definitions when it comes to these and a lot of new stuff. It's more than just area and circumference and radius and diameter. A little bit more than that. All right. So just a formal definition of a circle. It's the set of all points in a plane that are equidistant from a given point called the center of the circle. You know the radius. The radius is that distance from the center to any point that exists on the circle. And to have two circles be congruent, they have to have the exact same radius. And then a diameter is the distance across the circle, and it has to go through its center. So here's a diagram to go along with that. So the way that we name a circle, you can kind of see it right down here. We use the symbol circle like this, and then we name it by whatever the center point is. So the center is here at P, and so we name this circle P. So the radius is going to go from that center to any point on the circle here, and they're all the same length, and then the diameter has to go through it. And in order for me to have a circle congruent to this one, I would need to have it where it has the exact same size radius. And that's how we know the circles are congruent. These are the new stuff that you may or may not have heard before. So the first is a chord. A chord is any segment, again, it's a segment, not a line, whose endpoints are on the circle. So here's an example of a chord. As you can see, it doesn't have to go through the center, although a diameter is a special kind of chord. We just need to have it where we have 2 points that are endpoints sitting on the circle. So you can get smaller or bigger just depending upon where we connect them. Again, it is a segment, not a line. That's important to note here. Once we draw a line, okay, that's when we get a secant. So a secant is a line that's intersecting a circle in 2 points. So if I were to name this segment MN, I'm only talking about a chord. Once I continue through that point, those points there, and I create a line, that's the secant. So note the terminology and the stuff I have here, that line there, the symbols that we use for that to name it. Okay. The other thing we have is a tangent. So we work with tangents and right triangles. So now we're going to represent a little bit differently, but kind of keep in mind that tangents deal with right triangles. That's important to remember. But these is also another kind of line, and it's only going to touch the circle one time. And so if I tell you something is a secant, then I know that it's only going to hit the circle right here, only in that one single spot. If it's hitting twice, automatically becomes a secant. Okay, so it has to only hit one time. All right, so let's do an example using that terminology. So let's determine whether these guys are tangents, secants, diameters, or radius. So the first one is segment AH, this guy here. So if I notice segment AH is only hitting here at point B. Now it's okay for me to name segments outside. So I know that it was important for me to note that a secant, it goes through the circle and it doesn't stop within the circle. So if I do name a secant, such as GH here, I can name it as a line or a segment and still secant because those points H and G are outside. So I wanted to kind of point that out. Anyways, AH, I see it's hitting one time. So since it's hitting one time, that's a tangent. I'm looking at EI. EI has 2 points on the circle, so I can name it's a chord, but I see that it's going through the center. So the best description of this would be diameter. The next thing I see here is DF. Again, I have 2 endpoints on the circle, but this one is not going through the center, so this is just a chord. And then finally CE. So CE goes from the center to the side, so therefore it's a radius. Okay? All right, here's some more new terminology here. Again, we're jam-packed with definitions here, so you might want to get them written down. A tangent circle, these are coplanar circles that intersect in one point. So this will be an example of a tangent circle. We can draw a tangent right through here if we really wanted to, and they're only hitting at one single point. Okay, we did the best that we can. I know it might look like it's more than one, but tangent circles only hit one time. The other one is concentric circles. These are circles on the same plane and they share the same center. Okay, so this point here, we would actually, if we were to name this, these 2 circles would be named the same thing. The difference though is going to be their radius. Okay, the radii here, this one's going to be a lot shorter than that one. So they're concentric, but they are not congruent. Okay. Keep on going. Common tangents. These are a line or a segment that is tangent to two coplanar circles. So if I have two circles, whether they be attached to each other or not, I can identify common tangents. Now we've got two different types of common tangents. We've got internal ones, and these are ones where it's between two circles, and we have external tangents. So these are ones that are not with between the two circles, and I'll show you an example of that. So common internal, do you see how it's hitting each circle in one spot? And it's going right in the middle there. And then we have our self-external ones. So these are not going between the two circles. They're found on the outside. So circles have certain number of tangents that are shared. So here's an example here. We've got determine if they're internal or external. Hopefully you were able to kind of pick up on that terminology. We're going between our two circles. So those guys are obviously our internal, and these are on the outside. Okay, so those are our external. All right, two more. We've got the interior of a circle, and that's all the points that are inside the circle, and exterior of a circle. So hopefully that's something that makes sense to you. Exterior of the circle is on the outside of the circle. Point of tangency. Okay, this is important for us to understand. The point of tangency is where a tangent line is intersecting the circle. That's tangent when it's tangent. Okay, so we talked about what a tangent line was. Those are the lines that only hit at one point. Well, that point has a special name. And what's important to know that because we're going to do a theorem in a moment that uses that word point of tangency. Okay, so that right there is our point of tangency. All right, here's one of your theorems. You want to make sure this gets written down on that sheet of paper there for your little cheat sheet. So the big idea here is that if we have a line that's tangent to a circle, then it has to be perpendicular to the radius that's drawn from that point of tangency. So if you take a look at this here, I've got this tangent here, PI. What I know is if I draw PQ, so this is circle Q, if I were to connect a radius to any of the tangents that are drawn here, they have to form a right angle. So this is useful to us because we're going to do problems which involve right triangles. So let's take a look at our converse. That's also true. Okay, so if I tell you that we have ourselves a right angle here, then you can say that it has to be tangent. So if I'm trying to identify whether or not it is tangent, then you want to show that there's a right angle there. Okay, so here's an example of that. We want to decide if CE is tangent to circle D. And there's problems like this coming up on your practice and lesson check. So the way we do that is we want to make sure that there's a right angle and angle E. Well, thinking back to this, we have a triangle. Thinking back to Unit 6, we showed whether or not something was a right triangle by using Pythagorean theorem. So we're going to use that converse of the Pythagorean theorem. Since 45 is the longest, that's where we're trying to make sure that's the hypotenuse. That's going to go in for C. So I do 11 squared plus 43 squared and compare it to 45 squared. And what I see is that the 11 squared plus 43 squared is 1970. This is not equal to the 2025. Therefore, this guy is not a tangent. Okay, this has to be equal in order for it to be a right triangle. All right, next theorem. If two segments from the same exterior point are tangent to a circle, then they are congruent. Okay, so here's the diagram. Again, you have a place to put this theorem. I have myself two tangents here. These segments from the point of tangency to the point on the outside here on the exterior are going to be congruent. So RS has to be the same length as TS. Okay, so here's an example using that. I'm telling you that AB and AD are tangents, so they're hitting at one spot. Since they're both tangent, that means these guys have to be equal to each other. So AD has to equal AB. So that means I'm going to set x squared plus 2 equal to 11. And then from here, it's algebra. I'm going to subtract, and then I'm going to take the square root. Well, the square root of 9 actually is two answers. It's the positive and the negative 3. So this actually has two answers here, okay? Because if I were to substitute 3 or negative 3 back into x squared, I get back the positive 9, which is why it's both positive and negative. It's not always going to work out that way. So make sure when you find your answers, especially with square roots, you check both positive and negative. Okay, here's one that you're going to see both on your practice, your lesson checks, and your tests. So we want to find the value of the radius here. I'm telling you, you can see that it's a tangent based upon this right angle here. So what we need to do is once again take a look at the fact that we have that we're going to use the Pythagorean theorem once again. So what we have is here we have x, and this length here to here is 7. So if I'm giving you two pieces, that means this is the length 7, and that means this is x. If I only give you one number here, that means the whole length is that single number, okay? All right, so when I go to put this in the Pythagorean theorem, this is your x squared, this is your 12 squared, and that's a and b. To represent c, it's the whole quantity x plus 7. So this is what it's going to look like. I've got 12 squared plus x squared equals x plus 7 as a quantity squared. We're trying to figure out what x is. Okay, so now I got to think back to our algebra days when I see x plus 7 squared. Remember that x plus 7 to the second power, that represents how many times something gets multiplied. Like the 12 times 12 is 144. So what I'm going to do is rewrite this as x plus 7 times x plus 7. Okay, so now from here, depending on how you learn this, you might have learned it using the word FOIL, you might have done the box method, or distributing, just depends on how you do it. Okay, well this first one, what we need to do is distribute through that x to that x, and then multiply through with that x to that 7. And then I'm going to repeat that process with the 7. I'm then going to go through and I'm going to multiply, I'm going to do it a different color, this 7 through by that x, and that 7 times that 7. Okay, so if you learned the distributive method, that would be the process that you take. If you learn it from FOIL, that means first, outside, inside, last. And that would be doing x times x is first, x times 7 is 7x, and so on. So it just depends on how you learned it last year. But you need to multiply this guy together. So x times x is x squared, x times 7 is 7x. 7 times x is 7x, 7 times 7 is 49. Okay, and then we're going to combine our like terms. So 7x plus 7x combines to give us 14x, not x squared, just x. Well, what's nice is that we have x squares on both sides of this problem here. So that will just cancel out. Then from there, it's a matter of subtracting 49 from both sides. We get 95, and then divide by 14. In this problem, we do get a decimal, and that's okay. So I'm going to round to 2 decimal places. Okay, so hopefully you got a good idea on how this works. Give yourself a try. I know there's a couple on your practice for you to do. The answers are going to be posted where it has everything step by step written out, I believe. So take a look at that. If not, please make sure you ask your teacher. And that's all for this video. See you later.